So, a study indicates 7% of the American teenagers have tattoo. You randomly sample 12 teenagers. What is the likelihood that exactly 3 will have tattoo? Likelihood less than 4 will have tattoo. What is the likelihood? More than 2 will have tattoos. Right. So now, what we do, we take 12 people. So we take 12 people. So we got what is now for a variable to be binomial, there are 3 conditions last week we discussed. So we have to have a Bernoulli trial repeated for a fixed number of times. And the variable should be defined as total number of successes. So if those 3 conditions are satisfied, it becomes a binomial variable, right? Bernoulli trial repeated for a fixed number of times. Variable should be defined as total number of successes, right? So now here we take 12 teenagers. So we take 12 teenagers. So here we have 12, right? Now the first teenager, we check whether he is having a tattoo or not. If he has a tattoo, it is our success. If he don't have a tattoo, then it's a failure. So checking whether the first teenager is having a tattoo or not is like a Bernoulli trial, right? Then you check the second one. Having or not, Bernoulli trial. Having or not, Bernoulli trial. So how many times a Bernoulli trial? How many times we are going to repeat? First condition, okay. Bernoulli trial, repeated 12 times. Now the variable should be defined as total number of successes. Now here if you look at the problems or the questions, what is the likelihood that exactly 3 will have tattoo? Less than 4 will have tattoo. More than 2 will have tattoo. So to answer these questions, how we should define 2 things. How we should define the variable to get the solution of these ones, plus that third condition also should be satisfied, right? So what is the third condition? Number of successes, total number of successes. So how we should define the variable? We have to decide how it should be defined to satisfy that third condition, plus to be able to answer these questions. You just tell me. If we define in what way we can answer this question, plus that third condition will be satisfied. So the theory says it should be total number of. Number of katandarayak. There should be a number of what? Number of teenagers having tattoos. Okay. So we have ready-made, right? You have everything. You have to just plug in, get the answer. That's it. Identify you should be able to define the X. Just to have everything. Okay. So to answer these questions, plus to satisfy that third condition, X should be defined as total number of teenagers with tattoos. Total number of teenagers with number of then only the third condition will be satisfied, right? Number of whatever you take as success, right? Teenagers with tattoos, right? So first we have to define the variable, right? So variable we can define. Right. the variable X, total number of teenagers with tattoos. Okay, so variable defined. Now, balagana sequence, right? Variable defined. Then for a binomial, you need parameters. How many parameters are there? Two. N, P. Right. So now, what is our N? What is our P? P is number of repetition. Now, how many people we took? 12. And we are going to repeatedly check those 12 people. So we are going to repeat 12 times. So N is 12. Then P, in a single trial, the success. So when you check a person, what is the probability of he being having tattoo? The 7% of the teenagers are having tattoos. So the P will be 0.07. Right. So now we know, according to the way we have defined this variable, this will follow a binomial. So if it is a binomial variable, we know how to denote X, that tilde, bin, and so on. So we use that notation now. X follows bin. X follows bin. N is 12. P is 0.07. Okay. So now variable identified, parameters identified, distribution identified. Now binomial distribution as a probability function because we want to answer some probability. So we need the probability function. So then next we have to write down the probability function. So to write down the probability function, we have a general probability function. NP value and you recall that. So what is recall that general probability function? PR X equals X. NCX P to the power of X 1 minus P to the power of N minus X. Then we put the colon. What are the values X can take? 0, 1, 2, up to the general one. When you recall the general one, now you know your N value and P value. Just plug in those values. Get your probability function. So recall this, get your probability function. So we write our probability function. PR X equals X. Right. NCX. So 12CX. P that is 0.07 to the power of X. 1 minus P. So 1 minus 0.07. So that is 0.93 to the power of N minus X. So to the power of N minus X. So it will be 12 minus X. Then what are the values this X can take? What are the values X can take? So starts at 0, goes up to N. So here starts at 0 and goes up to 12. Colon X equals 0, 1, 2, and goes up to 12. So we have written our probability function. Right? So we didn't do anything. We pick that general one, we plug in and then that's all we need. So here I simplified 1 minus 0.7, I have put it as 0.3, right? So now we have the probability function, so we can answer that question. So 1 by 1 will take, so the first one, right? What is the probability of exactly 3 will have tattoos? So what we need to find? Probability. Yes, probability. Exactly 3 equals tattoos. Another value better substitute කරන්න what? What is X? Number of people having tattoos. Now I want probability of 3 people having tattoos. Probability of 3 people having tattoos. But I have to substitute the appropriate value for X. So what should be the X value? 3. So probability. Number of people having tattoo is 3. So this side, instead of X, I have substituted 3. So this side also you put the same thing. So 12 C 3.07 to the power of 3, 0.93 to the power of. So in the last class, I think I told you how to get this using a calculator. So same way. Okay, so we need to translate. Right. So x equals 3. So probability of exactly 3 people having tattoo. Yes. Right. Next part. Less than 4 people having tattoos. Less than 4 people. So second part. Second part. Probability x less than 4. X less than 4. Right? Less than 4 people having tattoos. So what are the possibilities? 0, 1, 2, 3. 4 not possible because equal sign is not there. So yes, 0, 1, 2, 3. So each probability we have to calculate and add because all are possible. So this is equivalent to probability of x equals 0 plus probability of x equals 1 plus probability of x equals 2 plus probability of x equals 3. So we can substitute for each, right? So we substitute for each. Right. So here 12C 0.07 to the power of 0.93 to the power of 12 plus 12C 1.07 to the power of 1.93 to the power of 11 plus 12C 2.07 to the power of 2.93 to the power of 10 plus 12C 3.07 to the power of 3.93 to the power of 9. So this one you don't have to recalculate. Right? The first part answer is there, so no need to calculate this again. Only these three you have to calculate. So take this one, substituted 0 for x. This one substituted 1 for x. This one substituted 2 for x. This one substituted 3 for x. It's a formula, that probability function. Correct? I see. It goes in a sequential way. See 12C 0, 0, 12. 12C 1, 1, 11. 12C 2, 2, 10. 12C 3, 3, 9. Ninety-nine, 25. Those individual values, if you want. Individual values. The individual values 0, 1, 2, So when you have to do the same kind of calculation repeatedly, you can give this as a function in your calc. Just you put the x value, you get the answer. That way you can do. Let me. So in your calc, they were shortcut. They were now lazy. You can easily do the things. Right. Say now, the general expression, if you take, it is like 12cx 0.07 to the power of x 0.9 into 0.93 to the power of 12 minus x. So this is the expression you need to calculate for different x values, right? So you are repeatedly doing the same thing for different values of x, right? So you can give this function into your calc and you can calculate easily, right? So now in your calc, can you identify you have a key called alpha here? Top row, second or third key from the left, alpha in an orange color, right? So you have this alpha key, right? Then in your calculator, there is a x. Not on the key, above the key you find an x, right? I think it is above the close bracket, carry open bracket, carry above the open bracket or close bracket, you have this, close the open, close bracket. So above the close bracket, you have x, right? Okay. And then there is another key called calc. Calc, here like okay. Maybe below that alpha key, maybe 2 keys down or something. Calc here, right? Second row calc. Okay, so we need those keys and you should be in the ordinary calculation mode, right? SD, RG, REG, whatever, who put at the end, right? You can just in your calc, the top part should be free. You can have just that D, right? Decrease. But REG, SD, if you have, you have to come back to the normal calculation mode. Right? So now we have to give this function, right? This function. So you need a, right? So how to give this? Now, first 12, right? 12. C. So to get this C, we put shift division. Shift division. Then we need X. In order to get this X, you put the alpha key, right? You press the alpha key and then the close bracket. Right? So when you finish up to this level, your screen would look like, right? Your calculator screen would look like 12 the X. Capital X or simple X or X, you can see, right? When you come up to this level, right? So now this part is over. Now here you have multiplication. So now next multiply 0.07 to the power of, so you can have either this key, power key, or this key you can have. If you are using the tool calculator, x to the power of y key. Whatever key you can use here, whatever available, right? Okay. To the power of x, I, alpha, close bracket. So now when you come up to this level, your screen would look like this into, right, into multiplication. Then 0.07 to the power of, index according to your calculator to the power of x. Right. So up to here we are done. Again into again into 0.93 to the power of right, to the power of now 12 minus x. So you have to put a bracket there, right? So space is not enough. So bracket 12 minus x. X is alpha key. Close bracket key. Make an x second. You have opened up a bracket, so that bracket should be closed. 0.93 to the power of 12 minus x bracket closed, that is this open bracket closed. Right. So now when you put all these, now here you can see into 0.93 to the power of 12 minus x. Right. Function given. Now, when this is appearing in your screen, don't press any other key. So you have this calc key, the calc key. So when this is appearing in your in your screen of your calc, press the calc key. So when you press the calc key, your screen will ask x equals what here. මෙතන මොකක් හරි garbage value එකක් එන්න පුළුවන්. එයා දෙන්න පුළුවන් x equals 20 x equals 0.5 ඔන්න මොකක් හරි garbage value එකක් එයා දෙන්න. ඒක ගණන් ගන්න එපා. So it is asking for x. So we have to give the value, right? So what is the first value we have to give? මුලින්ම හොයන්න x equals 0 නේ. Right. So when it is asking for x, give 0 equal. You get the answer straight away. Right. So next, again you have to calculate. Calc, it will ask for x, give your value, 1 equal. And it value. Calc, ask for the value, it will ask for the value, give the value. You can pick it. So when you are doing this, don't press any other key, right? Is it good? I don't know the function, right? A function calc value equal, calc value equal until you finish off that routine. You can check the values in the So those are the values. Those are the values. that is that power key මේක නේද? The power key එක. හරි මෙයාගේ 0.30 to the power. ඒකට ඒක ඕන එකක් whatever the key you have in your can you can use. අමන්නේ මොකද ඒක කන්ට්‍රෝල් කරන්න හොඳ නෑ කන්ට්‍රෝල් කරා අපි කියලා ඒවා ධර්මවල ඒක හොඳ නෑ ෆොටෝ එනේ ගන්න ඒක බ්ලොක් කරාම ඒක නෑ okay right so we have one last part there the greater than 2 greater than so third one probability X greater than 2. Number of people with tattoos. More than 2 people having tattoos. So now, if we try to directly calculate what are the possible values greater than 2, 2 bad, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So many values we have to calculate. So what are the values we are not calculating here? Or what are the values we are not considering here? 0, 1, 2. The values we don't consider is less than the values we consider. Directly if we go for the reverse, it's easy, right? So we have all the values from 0, 1, 2, 3, 5, 4 up to 12. So now we need more than 2. So we need all these. So if we are directly calculating, we have to calculate from 3 up to 12. So 10 pieces we have to calculate. But we are not considering only 3 pieces. So it's easy for us to calculate these 3 pieces. Full probability is 1. So from 1, if you remove these 3 pieces, you get the probability of that. So we go for the reverse. So this is equivalent to 1 minus probability X. This is greater than, the original version is greater than. So we are going for the reverse. So less than or equal to 2. So the original expression doesn't have the equal sign. So the reverse will have the equal sign. So now 1 minus. Here, what are the possibilities? Probability X can be 0, X can be 1, or X can be right. So all these have been calculated, so we can just plug in the values and get the answer, right? So already calculated, just substitute the values and get the answer. I thought that's the final answer after subtracting from one. Okay. So in this problem, the main thing is identification, right? That this is binomial. After that, all the things are like recipe. You have the formula for probability. Using that, whatever we are asked, we just calculate it. Okay. So since already all these values we have calculated, so just plug in the values here, subtract from one, the addition. Maybe there can be slight difference in your last value here, so that's okay, fine. Next, we'll take another example. Next. Okay. Oh, I was looking at here. Look at here. Multiplication So, go through the paragraph and identify in what form or what way we have to define the variable to answer this question. In the meantime, what we are defining should follow binomial also. We have done only binomially, right? So a company owns 400 laptops. Okay. Each laptop has 8% probability of not working. You randomly select 20 laptops for your salespeople. What is the probability that 5 will be broken? So now to answer that question, how we should define the variable? Success katandari we can define as we want. Kadila tibbana ඒක success කියලා ගන්න පුළුවන්, no issue, right? We can define our success according to the way we want. But even if you how we should define by number of no issue. Okay. Number of working computers number of broken laptops whatever. Working success probability will be different. Right? 0.8 neme, 0.08 neme, 0.92 right? If you take it as number of broken laptops, success probability will be 0.08. Right? So you can define either way according to what you feel easy, you can define. Right? So X number of broken laptops. If you prefer to define a number of working laptops, no issue. So N will be the same. P you have to put correct. Right. So variable identify. Then parameters N, P, two parameters. What is N? 20 the 420 the 20, right? 400 that is given there just to confuse the thing, right? We take only 20, let them have whatever number they have, right? We are taking only 20, so that will be our N. Right? P, success probability. So if it is broken, I am taking as success, so it is pointing. So here also this is going to follow binomial. So you take 20 laptops. First one you check whether it is broken or working. Success or failure. Bernoulli trial. Again you are checking Bernoulli trial goes on up to 20 times. Bernoulli trial repeated 20 times, and we are defining the variable to be total number of successes. All the three conditions satisfied. So this is going to be binomial. So now we can say this X follows binomial. What is the mean value? 20. What is the standard deviation value? 0.0. Now the probability function. So recall the general one, plug in your value, get the probability function. So PR capital X equals simple X. NCX P to the power of X 1 minus P, so 0.92. 0.92 to the power of N minus X, so 20 minus X. So then we have to mention what are the values this x can take. So x can be 0, 1, 2, 3 up to 20. So now what are they asking us? Take the sequence, right? Variable defined, parameters identified, distribution identified, probability function written. Are a sequence again, no, right? Okay. So then we can the first part exactly fine. First part is exactly fine. So exactly fine. First one. Probability of 5 broken. So we have taken a number of broken. So x equals 5. If you have defined it as number of working computers here, right? You have to go for 15. Right? 5 broken now, 15 should be working. Okay, values are in done, right? So still you get the same answer. There won't be any issue, right? So 20 5.08 to the power of 5.92 to the power of 50. So we are getting 1887. And then oh yes, yes. 5 done no 0 value we're getting at the so it should be 5, 5. Okay, 145. Yeah.
Into
So the next one is all working. All working. So all working. Now we have taken x to be number of broken. So if all working, what is the value we have substitute? X equals 0. Anit katana 20. So probability x equals 0. So 20 is 0. 0.08 to the power of 0, 0.92 to the power of 20. One minute.
This is again.
So 188. Right. So next one, probability all broken. Probability of all broken. The third part, probability x equals all broken. So it is x equals 20. Right. So 20C 20.08 to the power of 20.92 to the power of 0. Probability of all broken. What is the answer you are getting? One point 152. හරිද? එතකොට ඒ මම මේ ගණන් දාලා දෙන්නේ අවුල් වෙන තැන් ටික. Then okay, so when that is appearing in your screen, right? So see when that is appearing in your screen. Okay, 1 point ගානක් එනවා. 1 point whatever, right? 1.265 marker. මෙතන බලන්න either into 10 to the power of minus මොකක් හරි එකක්. නැත්නම් e to the power of minus මොකක් හරි එකක් තියෙනවානේ. එතකොට you have to read with that. නේද? එතකොට into 10 to the power 22 ද තියෙන්නේ minus 22. Minus 22 නේ. So that means what? Into 10 to the power minus 22 means now at the moment point is here. Edoda minus 20 into 10 to the power minus 22 means this decimal you have to shift this way 22 levels. Edoda make a plus now you have to shift that way. So 22 levels if you shift this way and if you write up to 4 decimal place what you get? Seriously. So the answer is ඒවා චුට්ටක් අර පරිස්සමෙන් බලන්න. 1 point කොහොමද එන්න විදියක් නැහැ. It's a probability නේ. Max you can have one. Not book beyond that. Who's according to the latest police reports, 85% of all crimes are unresolved in your town. Last month, 4 such crimes are committed in your town. The 4 crimes all are independent of each other. From the data given, what is the probability that one of the 4 crimes will be resolved? So let me say 85% unresolved. Okay. Last month, 4 crimes committed. What is the probability that one of the 4 crimes will be resolved? First, right. So now you take the 4 crimes. First one, second one, third one. So you check now. You check the first one, whether it is resolved or not. Well, we try. Second, check resolved or not. Bernoulli, resolved or not. Bernoulli, resolved or not. Bernoulli. So Bernoulli trial repeated 4 times. In order to answer this question, how we should define the variable? So somehow it should be number of, here I know number of what? Number of crimes resolved. Right? They have given unresolved probability, but here they are asking for resolved probability. So if this is given, other one is 0.15, right? Okay. So according to what they asked for, we define the variable. Having make unresolved, the value you substitute should be different accordingly, right? Okay. So now x we have to define. So x is number of crimes resolved. N is 4. P now it is resolved. So 0.85. So it is 15%. So 0.15. Variable identified, parameters identified. Already we have checked that this is a binomial variable. So x follows bin with 4 and 0.15. So variable identified, parameters identified, distribution identified. So we know this as a binomial distribution. So there is a probability function. So we have to write down the probability function. So probability x equals x. NCX p to the power of x. 1 minus p to the power of n minus x. What are the values this x can take? 0, 1, 2, 3, 4. That's it. So now what are they asking us to find? What is the probability that one of the 4 crimes will be resolved? Another one. Probability x equal OC1 0.15 to the power of 1, 0.85 to the power of 2. Simplify and give the answer up to 4 decimal place properly. Now, so see, even if the question is a big sort of a question, just 5 or 6 lines on this. So the main thing is identification. Beginning identify you have everything, right? Probability function is there. So just to plug in and get the values. So for example, all right. Yes. Right. So I have some more problems about that. We don't have enough time. So you can just snap it up and share that. Right. So this is the first problem. Right. So when you have free time, you can try. So if you are finding it difficult, then you can ask me. Already share that. So that's the first one. At most, we have discussed at most four or less, right? At most, right? Those the term one. Make a product, Srilanka. Okay, next one. All binomial type problems. ठीक है आपकी नहीं का यार so here you have two examples what have been naraga like they come you know they come kara okay right picture I think two or three they got kind of right okay so they got try color okay so we'll move on to the next. Okay, so for a variable to be binomial, preconditions, Bernoulli trial, repeated for a fixed number of times, variable should be defined as total number of. So when you answer, the sequence should be define the variable, identify the parameters, identify the distribution. If there is a probability function, we need the probability function. So next one, Poisson distribution. Poisson distribution. The second distribution, Poisson distribution. So this is actually not Poisson, this is Poisson distribution, the French word, Poisson distribution, but it's easy for us to say Poisson, so I'm using as Poisson, so we don't use it as Poisson distribution, right? So now, for a variable to be binomial, there are three conditions need to be satisfied, three conditions. So, do we have any conditions for Poisson? No, Poisson doesn't have any condition, but if a variable is defined in a particular format, if the variable is defined in a particular format, then it belongs to Poisson, right? So there are two formats where the variable will be Poisson. So we look at that, right? Okay. then take down this field. So as I said, there are two formats which we want to. So underneath you can write down a random variable, a random variable, random variable, if a random variable, sorry, a random variable, if a random variable is defined, if a random variable is defined in, a random variable is defined in any of the following two formats, in any of the following two formats, if a random variable is defined in any of the following two formats, then it is a Poisson variable. Then it is a Poisson variable. It is the Poisson variable. Right. So what are the two formats? One by one, okay? So first category is first bullet point or number one, whatever. Right, first category. Number of occurrences in a fixed time period. Number of occurrences in a fixed time period. Second category, we will have some examples and then we can. Number of occurrences in a fixed time period. Right, so if a variable is defined in that particular format, then it will be Poisson. A number of occurrences during a fixed period. Say number of accidents in 1 month. Satisfied everybody? So that's a Poisson variable. Or number of people joining a queue in 10-minute intervals. Number of people joining a queue in 10-minute interval. Poisson distribution. Condition is satisfied. Number of occurrences during a fixed period. Or number of radioactive particles emitted. Number of radioactive particles emitted during 1 second. Number of radioactive particles emitted during 1 second. Number of power breakdowns during a year. Poisson. Right? Number of happenings during a fixed period. It's important that fixed period when the moment. Right? Fixed period can be anything, maybe 5 seconds, then number of particles emitted, maybe the second radioactive particles emitted during 5 seconds. Power breakdowns during a month, number of accidents during a year or every 6 months. Right? So number of happenings during a fixed period. Okay, right. So that is the first category. So we'll write down some example for that. Number of accidents during a month. Number of accidents during a month. Number of accidents during a month. Next example. Number of people joining a queue. Number of people joining a queue during 10-minute intervals. During 10-minute intervals. Number of radioactive particles. Number of radioactive particles emitted. Number of radioactive particles emitted during 5 seconds. Number of radioactive particles emitted during 5 seconds. Right, so all those are number of occurrences during a fixed period. Right. So now the second one. Second one. Number of items in a fixed volume or area. Number of items in a fixed volume or area. Number of items in a fixed volume or area. Fixed volume or area. It can be a volume or it can be an area. Like say, like number of tadpoles in 5 liters of lake water. Number of tadpoles in 5 liters of lake water. Number of items, fixed volume, 5 liters. Right? Say in 100 liters. Or else say number of mosquitoes in 10 meter cube volume. Number of mosquitoes in 10 meter cube volume. Right. Oh, okay. So that is volume, fixed volume. Number of items in a volume. Like number of printing mistakes on a page. Area items, right? Number of printing errors on a page. Or number of printing errors in 10 pages. Sorry, area right? Number of printing mistakes in 10 pages. And it also will be poison, right? So 2 categories, number of occurrences or number of happenings during a fixed period, or number of items in a volume or in an area. The second example. Number of mosquitoes in 10 meter cube. Number of mosquitoes in 10 meter cube. Another example, number of tadpoles in 5 liters of lake water. Number of tadpoles in 5 liters of lake water. So that is for volume, right? So another example for area, like number of printing errors on a page. So now if you take say metal sheets, right? Metal sheets, roofing sheets, number of damages. Right? Number of damages in a sheet of say 10 meters. So you can say, okay, so number of damages in a 10 feet sheet. Right? Number of items in a area. Right? Okay, so one example we wrote. So another one. Right, number of damages, second one, number of damages in 1 meter squared metal sheet. Number of damages in 1 meter squared metal sheet. So all these are Poisson variables. So okay, always try to compare and study, then the things are easy. Right? And the binomial, when we discuss, first we said, okay, this is defined this way, this is binomial. Then we talked about how many variables are there for a binomial. We discussed how to denote a binomial variable. Then we discussed the probability function of binomial. So the same sequence here also. Right? Now we have defined how, if it is defining one of this format, it is Poisson. So next, how many parameters are there for Poisson? How do we denote the Poisson variable? Do we have any probability function for this? Okay, right. Other sequence we have to discuss. Right. So next para, a Poisson variable. A Poisson variable has one parameter. Poisson has only one parameter. A Poisson variable has one parameter. One parameter. So that is lambda. Right? Lambda. What is that? Lambda is the mean of the random variable. So lambda is this. If you write lambda. So like this lambda. Lambda, that is the mean average of that random variable. So this has only one parameter. Then how do we denote the Poisson variable? Right. The next para. Let capital X be a random variable. Let capital X be a random variable following Poisson distribution. Let capital X be a random variable following Poisson distribution. Following Poisson distribution with parameter lambda. With parameter lambda, because it is only one is there. With parameter lambda. Then it can be denoted by, either, so there are two notations, denoted by either the same way, right? X follows, it is Poisson, so we can use the three letters POI and within brackets the parameter, only one parameter is there, so we can use that parameter. So either we can use the first three letters or we can use the first two letters, both are accepted. X follows PO lambda, right? So either POI lambda or PO. එතකොට binomial එකට you can't use two letters. Bi and P කියලා ලියන්න විදියක් නැහැ. So that is not accepted. So here two letters. So now, do we have a probability function for this? Now Poisson variable, how it is defined? පළවෙනි category එක ගත්තොත් number of happenings during a fixed period. Right? Number of happenings or number of occurrences during a fixed period. So what is the minimum value that variable can take? 0. You can't say -5 happenings happen during 10 seconds. You can't say, right? The minimum is 0. 1.5, 1.7, not possible. 0 possible, 1 possible, 2 happenings, 3 happenings possible. But binomial has an upper bound. Right? If you repeat, say 100 times, you can't get 101 successes. And 0 to n binomial event. Now here, no upper bound. Minimum is 0, maximum can move up to any level because there is no upper bound. Okay, so X can take any integer value or binomial. Poisson variable can take any integer value. Minimum value is 0, maximum value is not this one. It can do more. But when you take higher values like 1,000, 1,500, whatever, the probability may be very minor, but still there is a chance. Okay. Binomial, if n is there, you can't go beyond that. Okay. Right. So this is also a discrete type variable. Binomial, sorry, Poisson is also a discrete type variable. Discrete type variable now, because it takes the value like digital type 0, 1, 2, 3, 4, 5, 6, like that it jumps, right? So this will have a probability function. Now, what is the probability function of this Poisson variable? And so next para, you can take down this bit. The minimum value a Poisson variable can take the minimum value a Poisson variable can take is 0 while the maximum value is not restricted, while the maximum value is not restricted. Further, it can take any positive integer. Further, it can take any positive integer. Therefore, Poisson variable has a probability function. Poisson variable has a probability function. Has a probability function. First up, the general probability function. The general probability function of a Poisson variable. General probability function of a Poisson variable is given as follows. So, next para will write down. If x follows PUI Poisson lambda, then you better use capital P. It should be capital. Right? X follows capital PUI point. Right? PUI lambda, not simple. If x follows Poisson lambda, then the probability function of the variable x is given by, then the probability function of the variable x is given by PR x equals x, capital X equals simple e to the power of minus lambda, lambda to the power of x over x factorial. E to the power of minus lambda, lambda to the power of x over x factorial, x and the exclamation mark, x factorial. E to the power of, simply, e to the power of minus lambda, lambda to the power of x over x factorial. And then colon, what are the values x can take? So x can take 0, 1, 2, 3 and go on. So if we need to find probability, like in the previous case, we use. So now this E is a special constant. E is a special constant. This E is a special constant. E is a special constant. And the value of this E, the value of this E can be obtained through this key combination. Right? So E is so this is the key combination to get that E. So if you want this E, shift LN1 equal will give you the value of this. Shift LN1 equal. So 2.712818. Right. So if you want the E value, you want that E value, so that is how you get. Shift LN1 equal. That key combination will give you the value of this E. And 2.712818. Then when we do examples, I will explain this. Right. Then the x factorial, right? X factorial. In your calculator, you can get this x factorial. X factorial. Say like 1 factorial, 2 factorial, 3 factorial, 5 factorial, 7 factorial. So you want to get these values, right? Factorials. So how to get these factorials? In your calculator, there is a key to find the inverse. X minus 1. Get a key. X minus 1 key. There is x minus 1 key. Above that key, you have this more stuff like right? So that works with shift, right? Factorial. So 3 factorial means from 1 to 3, all the integers you multiply. 3 factorial now 1 into 2 into 3. Answer. Right? 2 factorial 1 into 2. 5 factorial 1 into 2 into 3 into 4 into 5. Right? From 1 up to whatever the level, all the integers you multiply. That is the factorial. 7 factorial now 1, 2, 3, 4, 5, 6, 7. You multiply whatever you get. That is the factorial. Right? Okay. So now suppose we want 7 factorial. Suppose we want 7 factorial. So what is the key combination we go for to get this? Right. So this is you put 7 factorial. So shift X inverse equal. So you get the value. Seven shift X inverse equal. You get the answer. Right? So we want say 5 factorial. So 5 shift X inverse equal. Are we ready? Okay. So apart from this, you need 0 factorial. Right? 0 factorial. එතකොට ඒක අර definition එකට set වෙන්නේ නැහැ, right? So say 5 factorial na 1 to 5 all the integers you multiply. 7 factorial 1 to 7 all the integers you multiply. 6 factorial 1 to 6 all the integers you multiply. But 0 factorial, so 1 to 0 අනිත් පැත්තටනේ යන්නේ. So that definition won't suit for this. So 0 factorial is separately defined as 1. Galle dammat 0 factorial is 1. Right? Okay. So how about 1 factorial? 1 factorial is also 1. Definition is 5 factorial na 1 to 5 all the integers you multiply. 2 to 2 factorial means 1 to 2 all the integers you multiply. So 1 factorial now 1 to 1 all the integers you multiply. So that is also 1. 0 factorial is 1, 1 factorial is also 1. Okay, right. So apart from this, in that expression, right, calculate කරන්න ඕන ටික කියලා දෙන්න දොර ලේසි එක right? So we have that probability function, right? The probability function we wrote is something like e to the power of minus lambda, lambda to the power of x over x factorial, right? This was the function. So we should be able to evaluate this expression. So now we learn how to evaluate this factorial part. Factorial then so apart from that, this lambda is a constant to the power of x that we know how to get. Now this part, how to get e to the power of minus lambda, right? Okay, now say you want to calculate this value e to the power of minus. You want to calculate. Right. So how do we, what key combination we use to get this done? Shift ln minus 3 to minus this key you use to get the minus. That is subtraction minus එක නෙමෙයි සමහර කැලවල වැඩ කරන්නේ subtraction minus එක කියවුවම වැඩ කරන්නේ සමහර එක. So this is that top part. You have a key like this with 2 brackets sort of thing in with the minus and the key and 3 shift ln minus 3. So that will give you okay, so it will be a decimal value 0 point something, right? So if you have a kind of decimal value here, e to the power of minus 4.7. E to the power of minus 4.7. Okay, if you want to evaluate. So then the key combination would be e to the power of minus 4.7. Shift ln minus 4.7. Okay, so now we know how to evaluate all the parts. Only three parts are there, so one part already known, lambda to the power of x part, you know. X factorial and the other. Now, so now let's see, what is the key combination to calculate this? We put e to the power of minus 3, 3 to the power of 5 over 5 factorial, right? So these are the type of expression you will get. So how to evaluate this? E to the power of minus 3, 3 to the power of 5 over 5 factorial. So what is the key combination for this? So the key combination will be 8 ln minus 3 into 3 to the power of 5, right? Division 5 shift 5 shift x inverse part is e to the power of x. This is e to the power of minus 3. This part is 3 to the power of 5. This part is 5 factorial. You can simplify. You will be getting a long, lengthy answer, right? 0 point something lengthy answer. 4 decimal place properly wrong. That's it. 0 point. Is this one you asking? Make power x to the power black එක අද use කරලා catch. Okay. 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 Make correct mark. Power එකට ගන්න. Right. It depends on the calculator. Always divide in a meter. So we told calculators you have this power calculator, power key. It's a very old calculator. You have this x to the power of y. So whatever the key you have. Okay. So now we know how to calculate this stuff. Okay, calculator we can calculate whatever the values we want. And it does. So now we'll take example. So if a variable is defined in two formats, it is Poisson. One is number of occurrences during a fixed period. Other one is number of items in a volume or area. Yes. Number of traffic accidents. Number of traffic accidents that occur. Number of traffic accidents that occur on a particular stretch of road. On a particular stretch of road during a month. During a month follows a Poisson distribution. Follows a Poisson distribution with a mean of 7.6. With a mean of 7.6. 7.6. Find the probability that less than 3 accidents will occur. Less than 3 accidents will occur next month. Less than 3 accidents will occur this month on this stretch of road. On this stretch of road. Less than 3 accidents occur on this stretch of road. So now, first we have to identify how we should define the variable x to answer that question. But what are they asking us to find? Find the probability that less than 3 accidents will occur next month on this stretch of road. How to define that? Yeah, that's another number. Accident, okay. So what are the number of happening here? During period during a next month during a month. Next month sector you got the point, right? So number of accidents per month. Number of accidents per month. Half a month in the be defined. Number of accidents per half a month, right? So according to what they ask for, we have to define. So next month, we define as month. Okay. So So X variable. Number of accidents. Number of accidents during a month. Number of accidents during a month. Right. So now we need the parameter. So parameter is lambda. So what is lambda? Lambda is the mean, mean of the variable. So now per month, what is the mean? How many accidents per month on average? 7 point. So lambda is 7 point. So now this variable is number of happenings during a fixed period, Poisson. Lambda is no. Now we can say X follows Poisson. Format right. So X follows Poisson with lambda, which is 7.6. So now this has a probability function. We can write down. So you recall the general one, plug in your value and get your probability function. So probability PR capital X equals simple X. Okay. So general one, e to the power of minus lambda. So e to the power of minus lambda 7.6 into lambda to the power of x. So 7.6 to the power of x over. So here it is multiplication, right? In over x factorial. Okay. E to the power of minus lambda, lambda to the power of x over x factorial. The function is okay. Now we have to say what are the values possible for this x. 0, 1, 2, 3, no upper bound. So probability function written. So what are they asking us? Find the probability that less than 3 accidents. Less than 3 accidents. So we have the probability function PR capital X equals simple X e to the power of minus 7.6, 7.6 to the power of x over x factorial, and the possible values for x 0, 1, 2, and so on. Right? Got it. Now what are they asking us? So they are asking us probability x less than. Next month there will be less than 3 accidents. What are the possible values for this? Then in 0, 1, 2, 3 not possible because equal sign is not there. Right? So here probability x can be 0 plus probability x can be 1 plus probability x can be . Right. So now we can substitute. E to the power of minus 7.6, 7.6 to the power of 0 over 0 factorial. I don't want to call one is 0 factorial is what? Here we need that, right? Oh, plus e to the power of minus 7.6, 7.6 to the power of 1 over 1 factorial. Plus e to the power of minus 7.6, 7.6 to the power of 2 over 2 factorial. So you can individually simplify and get that. අකුලට වෙන විදියකුත් තියෙනවා. So for this one also you can do the same thing. අර ගොඩාක් calculate කරන්න දෙන function එක දාලා calc ඒ විදිහට දාන්න පුළුවන් මේ function එක දාලා. E to the power of minus 7.6, 7.6 to the power of x over x factorial දාලා. But say you give the value 5 times. Mean value 7.6 kilometer. That number. So here you find the individual values, right? Individual values are there. And the final answer is also there. 0, 1, 8. Okay. Okay, Neda. So in this one, if you want, you need to calculate next. E to the power of minus 7.6, e to the power of minus 7.6, you have to calculate that. If you want, you can simplify this way also. Now here there are three pieces. So all the pieces have this e to the power of minus 7.6. Okay, you can take it out. You can simplify this a bit, right? E to the power of minus 7.6 you can take out. So if you take this out, this term, this is taken out from this term. So these two will be there inside the bracket. So this is 7.6 to the power of 0. Anything to the power of 0 is 1. Here in the bottom part you have 0 factorial. So that is also 1. 1 over 1 1. Here, right? This is taken out. 7.6 to the power of 1. So that is 7.6. Over 1 factorial is 1. 7. Here, this part taken out, there will be a 7.6 squared over 2 factorial is 1 into 2. So that is 2. So here we have 7.6 over 2. So simplifying this part is easier than that. So in this expression, you have to put that only once. Then bracket 1 plus 7.6 plus 7.6, so squared over 2. Same answer. Or else if you want, you can simplify this way also. Whatever the one you feel. Correct. Okay. Next we'll take this example. So I will just define the variable probability function and give you. So you can do the rest of the part, right? Yeah, I mean, when you develop the probability function, I will write that. The rest of the part calculation, let's try. Suppose the average number of people suffering a fever from a flu vaccine is 5.2. Use the Poisson distribution to identify the probability that one person suffers a fever as a result. More than 7 people suffer a fever as a result. So how we should define the variable again? So here they have given me the Poisson distribution. So how we should define the variable to answer this question? One person suffers a fever. More than 7 people suffer a fever. The Poisson binomial, somehow it starts with number of. Rest of the part we have to identify. Okay, so the number of. So from the question we have to identify number of people suffers a fever. Any part take a time. Make it like what we discussed, we can't say 1 week or 1 hour, we can't say. The week I become a state, another එක වෙලාවකට අන්න ඒ වගේ කතන්දරයක් දාන්න ඕනේ. Right, you got that point, right? So නිකන් එක වෙලාවකට නිකන් at any one time අන්න ඒ වගේ එකක් දාන්න වෙනවා මේකට. Right, so if you don't have a time interval, you put it that way, right? So say number of construction projects at a time. එක වෙලාවකට අන්න ඒ වගේ කතන්දරයක් you have to introduce, right? So here number of x is x is number of people suffering a fever at a time. That's the duration. වෙලාවකට වගන්නේ වගේ සීහදන්න, right? Okay. So lambda, say mean given lambda is 5.2. So they have given us that use the Poisson distribution. So x follows Poisson with 5.2. So we can write down the probability function now. Probability function right here. Probability PR x equals x. E to the power of minus 5.2 5.2 to the power of x over x factorial. What are the values x can take? X can be 0, 1, 2, 3 and so on. Right. Variable identified, parameter identified, distribution identified, probability function given. So now what are they asking for? The first part. One person suffers a fever. Now what are we have to find? Probability of x equals then second part. Right. More than 7 people suffers. More than 7 people suffer. So probability x more than 7. And 7. Okay. So how do we calculate this one? Make a okay, only one piece name. X equals 1. That's it. Now this one more than 7. What are the possibilities if we try to directly calculate? 8, 9, 10, 11. No upper bound. So we can't calculate. So what we do? Go for the reverse. Right? What are the values we are not considering here? 0, 1, 2, 3, 4 up to 7. We are not considering. So directly we can't calculate because it has no upper bound. So we go for the reverse. So how do we write the reverse? 1 minus probability x less than or equal to 7. The reverse. So in Poisson, if you happen to come across greater than probability, directly you can't calculate for any case. You have to go for the reverse. The original one doesn't have the equal sign, so the reverse will have the equal sign. So the method you have from 0 up to 7. 8 pieces you have to calculate. So radial calculate you will get used to this. Okay. Again, so other type we didn't discuss. So in the next class we do that type of examples.